In this video, I am going to solve the problem 5 from chapter 16, Waves 1 from Principles of Physics, 10th edition. Two waves are generated on a string of length 4 meter to produce 3 loop standing wave with an amplitude of 1 centimeter. So you have to read the question very carefully what they mentioned. Here you have only one string, and in that string there are two waves. And the length of the string is mentioned as 4 meter. So what is the length of the string? The length of the string is 4 meter. And this string has two waves which produce 3 loops, right? So loop number 1 here, loop number 2 here. Let's we take loop number 3 here, right? I will just complete. Understand? Okay. So what is the total length? The total length here they mention as L, which is equal to 4 meter. Okay. And its amplitude is given. So you have to read very carefully. What is the amplitude? This amplitude is the combination of two waves. So here they mention the amplitude Ym. I just write caps Ym, which is equal to 1 centimeter. So you have to convert this in terms of meter, which is 1 multiplied by 10 power minus 2 meter. And this is the combination of Ym1 plus Ym2. What is this Ym1, Ym2? This is the amplitude of the first wave. This is the amplitude of the second wave. Will join together to form one big amplitude, which is 1 centimeter. Clear? So that means if you want to find the answer for the amplitude of one of the wave, that will be the half of this number. Clear? So you have to be read the questions very carefully. Clear? Okay. Now in this wave, the wave is traveling with a speed of 100 meter per second. Clear? Let the equation for one of the wave be in the form of y of x comma t equal to ym sine of kx plus omega t. So they mention the equation for one of the wave. Clear? So what is the equation for one of the wave? Let's we take ym or y1, which is equal to ym1 sine of kx plus omega t. What is this k? K is the angular wave number. Omega is the angular frequency. What is this positive sign? Because in the equation they mentioned positive. So what they mention? The positive represent this wave is moving in the negative direction of the x-axis. So what should be the second wave? We can easily frame from this equation itself. So the second equation is y2, which is ym2. Ym2 stands for the second wave amplitude, right? So don't get confused. This is not mass. This is ym stands for the amplitude, 1 stands for the first wave, right? So ym2 sine of kx minus omega t, right? So what is this minus? This is moving in the positive direction of the x. Clear? Okay. Now we have to answer one by one. What are the amplitude? The amplitude, if you want to answer for the first question, as I already mentioned, what is the amplitude? The amplitude for this wave is 1 centimeter they mentioned. So if you want to find the amplitude of one wave, because they did not mention what should be the amplitude of other wave, so you have to see here, we are just going to find what should be the amplitude of the other wave. Other wave means for this wave. So here we got 1 multiplied by 10 to the power of minus 2 for the combination of the two waves. So what should be the amplitude of the second wave amplitude? It's half of 1 multiplied by 10 to the power of minus 2. So that means the amplitude of the second wave, let's we take this is our second wave, this is our first wave, this is our second wave. Clear? So the amplitude for the second wave, which we wrote the equation here, am I right? The amplitude for the second wave, better I can write ym for the second amplitude, so which is equal to the half of 1 centimeter, because it's a combination. This is a total amplitude. So what is the amplitude of the second wave? It's a half of this value. So you have to divide this number 1 multiplied by 10 to the power of minus 2 by 2. So you will get the answer for the second wave amplitude. What is that? The half of 1 multiplied by half of 1 centimeter is nothing but half of 1 centimeter, right? Which is the value, which is the amplitude of one wave. So better we have to write the value in terms of meter, which is 5 multiplied by 10 power minus 3 meter. How I got? I just simply divide the total amplitude divide by 2. So here the total amplitude is 1 multiplied by 10 power minus 2 meter. If you divide this number by 2, we will get the answer for one amplitude. Clear? Which is 5 multiplied by 10 power minus 3 meter. That is our answer for the first question. Clear? Clear? Okay. Now we have to go to the second question. What is given in the second question? We have to find what should be the wave number, angular wave number, angular frequency, and what is the sign in front of omega. We already wrote the sign. What is the sign here? The answer for the fourth question, we already give the equation. So the sign in front of this omega is negative because the first equation has positive sign. That is for the first wave. For the second wave, it's a negative sign. Am I right? Because in front of this omega, we have to put negative. So that is our theory question. So better we can, now we have to go for the second question and third question, and then for the final question, we can just come later. Okay. So in the second part, we are going to find what should be the angular wave number. So for this finding the angular wave number, first of all, we have to write the formula. What is the formula? K, angular wave number K, which is equal to 2 pi over lambda. So now in this question, the lambda is not given, but they mention it's 3 loop. Am I right? Better I can draw the diagram one more time. So you have 3 loop standing waves, right? Clear? And this is the total length of the string. What is the length of the string? They mentioned the length of the string is 4 meter, right? So now we have to identify how many lambdas are here. As I already mentioned in the previous question, if you have one loop, each loop has quarter of lambda. So that means how many lambda over 4 you have? Here we have lambda over 4. Here also we have another lambda over 4. It's very easy for calculating the lambda. Lambda over 4, lambda over 4, another lambda. So how many total lambda over 4 we have here? How many lambdas over 4 we have? 1, 2, 3, 4, 5, 6. 6 lambda over 4 we have in this length 4 meter. So that means in this length I have 6 lambda over 4. I can cancel this. This one is 2 times. This one is 3 times. Therefore, the lambda equal to 2 multiplied by L over 3. Right? And this L value is already given. So better, first of all, I'm going to substitute this, and later on I'm going to substitute the value. So if you substitute this lambda here, your angular wave number K, which is equal to 2 pi over 2L over 3, and this 3 will go to the top, right? So by that, this equation becomes 2 pi multiplied by 3 over 2L, right? Understand? Clear? Okay. Now I have to cancel this number. I can cancel 2 with 2, and the length is mentioned as 4 meter. So I'm going to substitute the value K equal to pi multiplied by 3 over length is 4. Let's see what is the answer for this angular wave number, which is pi multiplied by 3 over 4. Actually, I got the answer as 2.356. I got. So better I can round this value. Actually, I got lambda, which is equal to 2.35. Better I can round it to 4. Okay, so therefore K is equal to 2.4. If you want to calculate with the 2.35, no problem, you can go ahead. And what's the unit? It is per meter, right? So this is the answer for the second question. Clear? Okay, now we have to go for the third question, angular frequency. What is the angular frequency? angular frequency omega we have to identify from the equation. As we already use the relation. What is the relation? Speed, which is equal to angular frequency over angular wave number. I'm going to use this equation for getting the answer for this angular frequency easily. So therefore omega equal to V multiplied by K. K we already find from the previous question, and the V already given in the question as 100 meter per second. They mentioned this value 100 meter per second already in the question. So 100 multiplied by the K value is 2.4. That will be the answer for the angular frequency. So therefore omega, which is equal to 240, right? Because 2.4 multiplied by 100 gives you 240, right? And what's the unit? Its unit is radian per second. Clear? And the fourth question, I told you, we have to find what should be the sign in front of omega. Better we can write, because in the question they mentioned the first wave equation. What is the first wave equation? They mentioned ym sine of kx plus omega t. This equation they gave in the question, right? But what is the second wave? Second wave we wrote as ym sine of kx minus omega t. So what they ask in the question, what should be the sign in front of omega? So in front of omega, what is the sign? In front of omega, the sign is negative. Clear? Clear? That's it. This is the answer for the last question. Clear? Because you have two standing waves, two waves which is traveling in a string which forms three loop standing waves. That means if one wave is moving in the positive direction, means another wave should move in the negative direction. If the wave is moving in the positive direction of the x, this omega will have the negative value. If the wave is moving in the negative direction of the x, the omega will have the positive value. Clear? X negative means omega positive. X positive means omega negative. Clear? So keep this information in your mind. Clear? Understand? Clear? Actually, these are all the theory informations we studied from the chapter 16. Clear? That's it.